So now that we have a model, a classification model trained, we are going to look at how we can improve the accuracy of our model using a grid search feature by tweaking hyperparameters. Now this part is extra credit, and I advise if you're not very well versed with code and just algorithms in general, this might be you don't have to watch this section. I will also point out that this is a little bit out of my own scope of expertise, and I'm definitely not the best with hyperparameters, and I still have a lot to learn here, but I do want to expose you to it just so you know that it's out there. So first, I'm going to make a new section, and I'm going to call this section Model Tuning. And then I'm going to import from scikit-learn. I'm going to import model selection, and then I'm going to import grid search CV. Okay, and then the first thing I want to do is I want to create a dictionary that outlines the parameters of my grid search. So I'm first going to talk about max depth. And what this parameter is doing is if we go back to it's our decision tree, it's kind of telling us just how deep down will we want to go when we do this. So I'm going to pass in an array, going to use 3, 4, 5, 6, 7. I don't think I want it going any lower than 7 layers, else we'll risk overfitting. Then I also want to do sample leaves, which will just tell it how many leaves we want to have, or how many of these are we going to be expecting, or we want to explore having. So I'll just do 5, 10, 15, 20, 25, 30. And so what these parameters are telling the model is when you make your decision tree, it's going to look through all these different combinations of how to structure the tree. And then based on those different combinations, it's going to bring back whichever combination that most improves the accuracy of the model. Going deeper into that is out of the scope of this class. There's a lot of videos online that will go into more description of that. But for right now, we are just using this to try to increase the accuracy of our model. So I'm going to then use the grid search. Going to use our grid search function. I'm going to import our model, our decision tree model that we previously trained, and then I'm going to use the grid search parameters that we got, and that's going to get us our grid model. And then I want to fit that model back to our training data. Train. And then I want to get our best tree. And then that best tree is going to be equal to grid CFL dot best estimator and then that will get us our best tree. So if I run that, this tells us that the best tree that we can have has a max depth of 4 and has 10 sample leaves. So then, of course, we can get the accuracy of that. I'm going to pred y pred best is equal to best tree on the testing data I forgot to add predict here. Okay, and that gives us our y predict best, and then we can use our accuracy score. We can use our metrics. We'll come back up here to where we had accuracy. I'll just copy this down here. Call this best. And y-test versus y-test predict best. Okay, and you run that, we see that now our model has an accuracy of 93%. And if we compare that to what our previous accuracy was, we were at 86%. So we were able to, using this grid search, we were able to increase the accuracy of our model from 86% to 93%, which is pretty significant. And I also, we can go back up here. We'll just copy all the code up here and then bring that down here. And I'm going to change this from CLF to, I believe it was best tree is what we're looking at. And everything else should remain the same. Go ahead and run that. And then let me close that. And then this is where things get a little bit interesting. I can go ahead and look at these two trees side by side. So this was our original model that we had. And if you compare them, you see, okay, petal width, it both splits it at petal width. And it continues to split at, it splits again at petal width. However, when we come down here, this is where things change. So rather than using 4.9, this uses 5.5 for petal length, and then it splits it between these two. And so what's interesting here is how I would interpret what the grid search did was it helped the model be less fitted. So this model right here was overfitted to the training set, and because it was overfitted to the testing set, it performed poorly on the training set. Where this model, it found out that if it cuts out this level of depth, then let's see if we go back to the code here, we can see that our tree decided that the max depth was 3. So you see that this tree has a max depth of 4. 1, 2, 3, 4. And by having 4, that made the model a little bit overfitted to just the training data. But over here, if we keep it at the max depth being 3, that actually increases the accuracy of the model, making it so it can better predict the data. So hopefully that helps explain a little bit what the grid search does. It helps explain what depth is. It's limiting the different parameters of the algorithm to be able to increase the accuracy of it. So that's the inner workings of the algorithm right there. Let's also get a confusion matrix down so we can see what's going on. And I'm going to rename this confusion matrix just to CM best, and then going to make the modification here as well as CM best. If I run that, we have this confusion matrix. Oops, okay, wait. I also need to make sure that I add in our predictions as the Y best as well. So I can open this. I'll open up these two. So this was our original, and then this was after tuning. So I'll put this right here, and then this one over here. So now you can see the difference in how our model performed before we did the grid search versus after we did the grid search. Here it mislabeled versicolor. I'm sorry, I mislabeled Virginica 9 times and versicolor 1 time. Our new model still mislabeled versicolor once, but it only mislabeled Virginica 4. So that was an improvement, and it also got 5 more correct predictions for Virginica than our model without the hyperparameter tuning. So hopefully that's a good introduction to how you would tune a decision tree algorithm. Really quick, we can also get the CSV file for this as well. We'll do the exact same thing we did up here because I might want to add that into my analysis. Let's call this best. There we go. So that shows this updated confusion matrix. And then I'm just going to export that as a CSV file down here. Okay. Now we have 2 Excel files that we can play around with. We have our original, and we have our new one. And I can copy this and go back to our original, and and in the next video I'll get into going how to present this analysis. But before we finish, I do want to talk a little bit more about hyperparameters for decision trees and for tuning. I want to bring these two down. We have accuracy, and then accuracy best. There you go. Here you can see our accuracy that we had. This was our original accuracy. This is our original accuracy of 86%. This is our new accuracy for after tuning the model of 93%. And this is how much it increased in accuracy. Now that was run. I do want to very much emphasize though that parameter tuning is an art, and you really need to know what you're doing. The reason why, if I run all of this again, you'll see that in this case, my original, let me keep these from downloading. In this second iteration, when I ran this, my original decision tree actually outperformed my tuned decision tree. Let me go back up here and just make sure that doesn't download anymore. And then if I run this again, this time same thing. My new decision tree, my original decision tree outperformed my tuned decision tree. If I run it again, again, wow, all these times is actually performing worse. Here we go. Here's a time that it ran better. But as you can see, like it does depend a lot on the data. On this case, with the training data, how we split the training and testing data determines the um would really factor into how much the hyperparameter tuning will actually help improve the model. Um, the iris data is very clean, and because of that, there's not a lot of hyperparameter tuning that we can really do on it. But and before you just go ahead and start applying this code to all your algorithms, I really encourage you, especially if you're doing this professionally, to learn more about the effects that these parameters have on including on being able to tune your model and learning how they relate to your data so that you can dig into your data and figure out what kind of parameters should you throw into it to be able to tune your model and how that's going to affect your accuracy. And model tuning is really an art, and I think this lecture really demonstrates that.